Hello everyone, welcome to new class. Today's class is the continuation of string efficiency. So we are discussing about the problems related to string efficiency. So let us do the problems. A string of 4 insulators has a self capacitance equal to 10 times the pin to earth capacitance. Find the voltage distribution across various units expressed as a percentage of total voltage across the string and the string efficiency. So here there are 4 string of insulators. So in the previous classes we have discussed about 3 insulators. So here there are 4 insulators. So that is represented as the self capacitance C. So there are 4 insulators. Let V1, V2, V3 and V4 be the voltage distribution across these insulators. So that voltages we have to find, that is voltage distribution across various units expressed as percentage of total voltage across the string. So when the number of insulators in a string exceeds 3, the nodal equation method becomes laborious. So under such circumstances, there is simple method to solve the problem. So in this method, the capacitance C1 and self-capacitance C of each insulator are represented by their equivalent reactances. So here C1 and C are represented as XC1 and XC, that is reactances, and assume that XC is equal to 1 ohm. So always assume that XC is equal to 1 ohm, and also assume that the current through the top insulator, that is current through the top insulator, is 1 ampere. So here we assume that X is equal to 1 ohm, and also the current through the top insulator is 1 ampere, that is current through this one is 1 ampere. Then it is given that self capacitance is equal to 10 times the pin to earth capacitance, that is self capacitance is C. C is equal to 10 times the shunt capacitance, that is C divided by C1 is 10. So C divided by C1 is equal to 10, and if we assume XC is equal to 1 ohm, so XC is equal to 1 ohm, then what will be XC1? So we know XC is equal to 1 by omega C, and also XC1 is 1 by omega C1. So what will be XC1? So XC1 will be 10 ohm. So if Xc is equal to 1 ohm, then Xc1 will be equal to 10 ohm, because C divided by C1 is 10. So from this equation we will get Xc1 is equal to 10 ohm, because Xc1 divided by Xc is equal to C divided by C1. This Xc1 divided by Xc is equal to C divided by C1. So from this we can find Xc1. So Xc1 is Xc into C divided by C1. So we will get 10 ohm. So here Xc1 is 10 ohm, and if this current is 1 ampere, so here all these are represented in reactance form. So these are 10 ohm, 10 ohm, 10 ohm, and here reactance is 1 ohm, 1 ohm, then 1 ohm and 1 ohm. Now if this current is 1 ampere, then what will be V1? So V1 will be equal to current into that reactance, that is 1 into 1, that is equal to 1 volt. Then if this is 1 ampere, then what will be the current through this section, that is the first shunt capacitance. So the current through the first shunt capacitance, that is marked as 1. So current through the first shunt capacitance is equal to V divided by XC, that is V divided by XC. So this is XC1. So what is V? That is V1. V1 is now 1 volt. 1 divided by 10, that is equal to 0.1 ampere. So this is current through this one, that is I1. I1 is equal to 0.1 ampere. So this is 0.1 ampere. So this is 0.1 ampere and this is 1 ampere. Then what will be this current? That is I2. So capital I2 is equal to, so here we assumed I1 is equal to 1 ampere. Then I2. What will be I2? I2 is equal to the sum of these two currents, that is 1 plus 0.1, that is 1.1 ampere. So this current is 1.1 ampere. Then what will be V2? So now V2 will be equal to current into that reactance, that is 1.1 into 1 ohm. So we will get 1.1 volts. Then what will be the current through this shunt capacitance? So the current through this shunt capacitance is equal to, that is small I2. Small I2 is equal to V1 plus V2. The voltage drop is V1 plus V2 divided by XC1. So what is V1? V1 is 1. 1 plus 1.1 divided by X is 10. And we will get 0.21 ampere. So this is now 0.21 amperes. So this is 0.21 ampere and this is 1.1 ampere. Then what will be this current? That is I3. So capital I3 is equal to 1.1 plus 0.21 and that is equal to 1.31 amperes. So I3 is 1.31 amperes. Now what will be the current through this capacitance? That is current through this shunt capacitance, that is I3. So small I3. So before that we can find V3. So what is V3? So V3 is equal to 1.31 into 1 ohm. So 1.31 volt. Now we can find this current, that is small I3. So what is I3? So I3 is equal to V1 plus V2 plus V3 divided by XC1, and that is equal to V1 is 1 volt, then V2 is 1.1 volt, then V3 is 1.31 volt, and we get I3 as 0.34 ampere. So now this is 0.34 and this is 1.31. Now we can find the value of this current. So what is that current? That is, let it is I4. I4 is equal to 1.31 plus 0.34 and that is equal to 1.65 ampere. So what will be V4? So V4 is equal to 1.65 into 1 and that is equal to 1.65 volt. So V1 is equal to 1 volt, V2 is equal to 1.1 volt, then V3 1.31 volt, V4 1.65 volt. And the question is, find the voltage distribution across various units expressed as percentage of total voltage across the string. So to find the percentage of total voltage across each string, we have to find the value of total voltage. So what will be the total voltage? So total voltage V will be equal to the sum of these four voltages, that is V1 plus V2 plus V4. So total voltage V is equal to V1 plus V2 plus V3 plus V4, and all the values we got. So the sum of these four voltages is 5.06 volts. So V is 5.06 volt. Now we can find the voltage distribution across various units. So the voltage distribution across the first unit, that is top unit, is equal to, that is V1 divided by V. So V1 divided by V into 100. So V1 is 1. 1 divided by 5.06 into 100. And that is equal to 19.76 percentage. So similarly, second top unit, the voltage distribution across the second unit from the top is equal to V2 divided by V into 100, and that is equal to 1.1 divided by 5.06 into 100, and that is 21.74 percentage. Then third unit, that is voltage distribution across the third unit from the top is equal to V3 divided by V into 100, and that is equal to 1.31 divided by 5.06 into 100, and we get it as 25.9 percentage. Then across the fourth unit is V4 divided by V into 100. So V4 and V now, then we will get 32.6 percentage. So these are the voltage distributions across various units expressed as the percentage of total voltage across the string. Now we can find the string efficiency. Then what will be string efficiency? String efficiency is equal to total voltage divided by number of disc into the voltage nearest to the voltage across the disc nearest to the conductor into 100. So V is 5.06 divided by 4 into 1.65 into 100, and we get it as 76.6 percentage. So in the case of four insulators, we have to do the problems like this. So first of all, assume the Xc as 1 ohm. So all the capacitance values we have to consider as reactance. So not in farad. So we have to consider the reactance of these capacitance values and assume the self reactance as 1 ohm. Then assume the current in the top unit as 1 ampere. Then do like this. Let us do another problem. A string of 5 insulators is connected across a 100 kV line. If the capacitance of each disc to earth is 0.1 of the capacitance of insulator, then calculate the distribution of voltage on the insulator disc and string efficiency. So here there are 5 number of insulators. So in this method also we have to assume that Xc is equal to 1 ohm. So this value is 1 ohm, and here it is given that the capacitance of each disc to earth is 0.1 of the capacitance of insulator, that is it is C1. C1 is given as 0.1 of C, that is C1 divided by C is given as 0.1. So to find the value of this Xc1, so what is Xc1 divided by Xc? So Xc1 divided by Xc will be equal to the reciprocal of this one, that is 1 by 0.1, that is 10 ohm. So this value will be 10 ohm. So Xc1 is 10 ohm. Now assume this current is 1 ampere, that is I1 is equal to 1 ampere. Then what will be V1? So V1 will be equal to 1 into 1, that is 1 volts. Then what will be this current, that is I2, sorry I1, small I1. So small I1 is equal to V1 divided by 10, that is 1 divided by 10, that is 0.1 ampere. Then this current, that is capital I2, is equal to 1 plus this 0.1 ampere. So 1.1 ampere. So I2 is 1.1 ampere. Then V2 will be equal to 1.1 volts. Now what will be this current, that is small I2. So small I2 is equal to V1 plus V2 divided by 10, and that is equal to 0.21 ampere. So this is 0.21 ampere. Then what will be this current, that is I3. So I3 is equal to sum of these two currents, that is 0.21 plus 1.1 is equal to 1.31 amperes. Then what will be V3? V3 will be equal to 1.31 volts. Then small I3. So this current is 1.31 amperes. So I3 will be equal to V1 plus V2 plus V3 divided by 10, and that is equal to 0.34 amperes. Then we have to find the value of this current, that is I4. So capital I4 is equal to, so this current is 0.34 amperes. So 1.31 plus 0.34, and that is equal to 1.65 amperes. And what will be V4? So V4 will be 1.65 volts. So this is 1.65 amperes. Now we can find the value of this current, that is I1, I2, I3, I4. So small I4 is equal to V1 plus V2 plus V3 plus V4 divided by 10, and that is equal to 0.51 amperes. So this is 0.51 amperes. Then what will be this current? So capital I5 is equal to 0.51 plus 1.65, and that is equal to 2.16 amperes. Then what will be V5? So V5 will be equal to 2.16 volts, because this reactance value is 1 ohm. So current into that reactance. So this current is 2.16 amperes. Now in the question it is given that the string of 5 insulators is connected across a 100 kV line. So it is, the line voltage is given. So to find the string voltage, that is voltage across the string. So voltage across the string V is equal to, so that is the line voltage. So to find the phase voltage, we have to divide it by 3, root 3. So 100 divided by root 3 is 57.7 kV. So this is the voltage across the string. Now we have to find the distribution of voltage on the insulator disc. So we have to find the distribution of the voltages across each disc. So for that we have to find the percentage of voltage across each unit. So here we assumed that the current through the first unit is 1 ampere. Then we have find out the V1, V2, V3 like that. So here we have to find the percentage of the voltage across each units. So how will you find the percentage of voltage? So percentage of voltage across the first unit. So top unit is V1 is equal to 1 volt. So V1 divided by the total voltage V, we have to find it. That is into 100. And here what is total voltage V in these terms? So what is V here? So V is equal to V1 plus V2 plus V3 plus V4 plus V5. So V is equal to 7.22 volts. Now we have to find the percentage of voltage across each units. So what is V1 divided by V? So V1 is 1 divided by 7.22 into 100. So that is equal to 13.8 percentage. Then for the second, across the second unit, it is 15.2 percentage. Then across the third unit it is 18.2 percentage, and across the fourth unit it is 22.8 percentage. So these are obtained as V2 divided by V into 100, then V3 divided by V into 100, like that. Then across the fifth unit it is 30 percentage. So these are the percentage of voltage across each unit. Now we can find the voltage across each unit. That is, in kilovolt we have to find the voltage across each unit. So here we got the percentage of voltages. Then multiply the percentages of voltages with the voltage across the string. Then we will get the voltage across each unit. So now the voltage across the top unit is equal to, it is 13.8 percentage of the voltage. So 13.8 into 57.7 divided by 100, and that is equal to 7.96 kV. Now across the second unit is equal to 15.2 percentage of 57.7, and that is equal to 8.77 kilowatt. Then across the third unit is equal to 18.2 percentage of 57.7, and that is equal to 10.5 kV. Then across the fourth unit is equal to 22.8 percentage of 57.7, and that is equal to 13.16 kV. Then across the fifth unit is equal to 30 percentage of 57.7, and that is equal to 17.3 kV. So we got all the values of voltages across each unit. That is, V1 is 7.96, V2 8.77, V3 10.5, V4 13.16, V5 17.3 kilovolt. Next question is to find the string efficiency. So what is string efficiency? So string efficiency is equal to V divided by, so here what is V? It is 57.7 divided by number of disc is 5 into the voltage across the disc nearest to the conductor is V5, that is 17.3, and that is equal to into 100. So into 100 equal to 66.7 percentage. So in this way we are doing the problems related to string efficiency with disk more than 3. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.